So we're trying to find x-intercept, y-intercept, asymptotes, domain, range for f of x equals x to the second plus x minus 2 all over x to the second minus 2x minus 3. And finally, we are going to have to graph this rational function. Once again, the first question I ask myself that is f of x in its most reduced form? In other words, do I have a factor on the numerator that would cancel a factor in the denominator? Well, let's factor the top and bottom. So f of x equal, the numerator factors out to x plus 2, x minus 1. And the denominator factors out to x minus 3 and x plus 1. Let me double check myself, x forward. Yep, okay. And as you can see, nothing is canceling out from the numerator and the denominator. So this rational function f of x is on its most reduced form. It is in its most reduced form. So let's go to the next page and find x-intercept. So to find x-intercept, let y equal 0. So I'm going to set x plus 2, x minus 1 over x minus 3, x plus 1, set equal to 0. Remember that it is sufficient for the numerator to equal 0. I cannot set denominator equal to 0. You can also think of this actually if you want, if you, well, let me first say that if I say x plus 2 times x minus 1 equals 0, using zero product property, I get x plus 2 equals 0 and x minus 1 equals 0. And I get x equals negative 2 and x equals positive 1. Okay, so now some of you may ask that why is it sufficient for the numerator to equal, to be 0? And here is why. Suppose if I say x plus 2, x minus 1 over x minus 3, x plus 1 equals 0. 0, this 0 on the right-hand side, this is not 0 over 0. 0 over 0 is undefined. It's not a defined. 0 over 0 is, even if you put in your calculator, it will give you an error. So you can think of this as 0 over 1 or any number other than 0. So now if you cross multiply, or if you multiply both sides of this equation by LCD, you get x plus 2, x minus 1 equals 0. And that's what we had up here. So just a little bit of extra explanation. So let me go ahead and clean this up, this extra work, and say that x-intercept, so we have x-intercept at x equals negative 2 and x equal positive 1. Okay. Negative 2 and 1. And so let me go to the next page and to find y-intercept, let x equal 0. Let x equal 0. Remember in the beginning, I had x to the second plus x minus 2 over x to the second minus 2x minus 3. And that was equal to my f of x. So f of 0 equals 0 to the second plus 0 minus 2 over 0 to the second minus 2 times 0 minus 3. So I'm left with minus 2 over minus 3, canceling the negatives. I'm left with 2/3. So y-intercept at 0, 2/3. Okay. So now let's take a look at horizontal asymptotes. Well, I had x squared plus x minus 2. Let me actually put my f of x here to make it more legit. X squared plus x minus 2 over x to the second minus 2x minus 3. And the factor form was, let's see, x minus 1, x plus 2 over x plus 1, x minus 3. And to find the horizontal asymptote, notice that the degree of the numerator and the denominator are the same. So I have x squared here and I have x squared here. So the horizontal asymptote is going to be y over 1/1, which is 1. So horizontal asymptote at y equals 1. And how about vertical asymptote? Let me actually go to the next page. F of x equals, I'm going to write the factor form of x minus 1, x plus 2 over x plus 1, x minus 3. I'm going to set for vertical asymptote. I'm going to set the denominator equal to 0. So x plus 1 times x minus 3 equals 0. X equals -1 and x equals +3. So the next step from here, I use zero product property. I said x plus 1 equals 0 and x minus 3 equals 0. Solving the two, I get x equal -1 and x equals +3. So those are, I have vertical asymptote and vertical asymptotes at x equals -1 and x equals 3. And I don't have slant asymptote. I don't have to do any work for that. How do I know? Anytime I have a horizontal asymptote, I will not have slant asymptote. So no slant asymptote. If you want to be so fastidious about it, you can say that the degree of numerator is not higher by 1 degree. Okay. So now what's left here is domain, range, and graph. So let me first graph it to make it just, look at it and then decide what is the domain and what's the range. So let's see, if I put the x in here and then put the y in here. So this is y, this is x. And we have the x-intercepts at x equals 1 and x equals -2. Where was it? Oh, one page before this. Okay, x equals -2 and x equals +1 are the so put 1 and 2, and then +1 in here. So I had an x-intercept in here. I had another one at 1. And we said that we have the vertical asymptote at -1. So let me, -1. And you had another one at 3. Okay. So what else did we know? We had a y-intercept. We figured out that y-intercept was at 2/3, somewhere about. If so, let's say if this is 1, then 2/3 is somewhere in here. All right, and we know that we had a horizontal asymptote at y equals 1. So okay. Now I know that my graph gravitates towards the vertical asymptote. So I know that just in the middle is the easiest part. It's going to be like this. And if you are not sure, if you don't believe me, just plug in a couple of values of x and evaluate. And how about on the left-hand side? On the left-hand side, I do have an x-intercept at -1. So my graph is going through this point and it's going to gravitate about the asymptotes. How do I know? How do I know that the graph is not turned around? Because graph of any rational function will never ever crosses the vertical asymptote. It can cross the horizontal asymptote, but not the vertical asymptote. And I have, let's see. So if that is 1, 2, 3, so let's say 4, 5, 6. Okay, so now I want to know that what is going on to the right of 3. Remember that this vertical asymptote was one at -1, the other one was at 3. So if I plug in 4, the value of 4 in my rational function, I get 4 squared plus 4 minus 2 over 4 squared minus 2 times 4 minus 3. So that gives me 16 plus 4 minus 2 over 16 minus 8 minus 3. And that gives me 18 on the top, and it gives me 8 and then minus 3, so 5, 18/5. So 3 something positive. So this equals 3 and 3/5. So at 4, at the value of 4, my graph is clean this up. It's somewhere up here. Somewhere up here. So I know that this graph in this part is going to look like this. Okay. Once again, how do I know that, for example, this is not going like that? Well, if it was going like that, it would have crossed the vertical asymptote, and that's not possible, you know. And on the right in here, see, this is the only way that the graph is approaching the vertical asymptote and the horizontal asymptote. And I can't emphasize more that if you're not convinced, like for example, you could just find out that what is f of 5, and you would see that would be a point somewhere about there. What is f of 6? That would be a point about there. So if you're not sure, just keep plugging in numbers. How about the domain and the range? So the domain is all real numbers except x cannot equal -1 and x cannot equal 3. So you can say from -infinity to -1 together with, or union from -1 to +3 together with, from 3 to infinity. Remember, we never put bracket on the infinity because it keeps going. Or you could, some textbooks show it that x such that x cannot equal -1 and +3. Okay, how about the range? Now notice that, look at the middle part. This is going forever down and just keeps going forever up. So the range is all real numbers. So all real numbers, or you could say from -infinity to infinity. Okay, and hope you found this example interesting. Thanks.